Hello 3M, we're going to be starting Unit 5 today, which is about exponential functions. So we're going to spend a day or two looking at exponents just to see that we remember what they're all about. So first example would be 4 cubed, just to remind you that the power of 3 means 4 times itself 3 times. Everybody makes a mistake of saying that's 12 at least once, but that would be 64. We've got 4 times 4 times 4. Likewise, if you have a fraction, 3/4 squared, it would mean that thing times itself twice. So both the top and the bottom would be affected. Numerator's 9, denominator's 16. Put one on here with negatives just because we have a time sometimes getting this straight. So the one on the left says, I have a negative number, and that negative number is 4 squared. So I end up with negative 16. The one on the right, however, says I have negative 4 all being squared. That means negative 4 times itself 2 times. We get positive 16. So that square affects only what's directly before it. So on the left side, the square is affecting just the 4. It doesn't affect the negative. In this one, it affects the bracket, which means the whole thing gets squared. We'll take a little care when we're looking at those. When we have things that have multiplication, like 3 cubed times 3 squared, we could write that out longhand as 3 times 3 times 3, then times, that is another symbol for times, sorry about that, 3 times 3. So what we have is 3 to the power of 5, which I believe is 243. Calculators are all a little bit different. If you've got a new calculator, you're just not sure about yours, it's often 3 little hat 5 would be to the power of 5. Some calculators have 3x to the y button 5, and so on. Make sure that you can get to the same answers that I have. 3 to the 8th divided by 3 to the 5th could be written as 3 times 3 times 3, 8 times, oh man, I'm making a mess, divided by 5 3s. And we know that if you are dividing by a factor top and bottom, you can cross it off. As long as it's multiplication we're dealing with, both the numerator and the denominator, I am dividing out 3's in top and bottom to reduce this fraction to its simplest form. I end up with 3 to the power of 3, or 27. The last one I have here is 3 squared cubed, which means I have 3 squared times 3 squared times 3 squared, which means I have 3 times 3 times 3 times 3 times 3 times 3, which would be 3 to the power of 6, or 729. So you have a summary sheet, and we're going to put a few of these rules on our summary sheet so we can deal with powers in the most efficient way. The first rule that we looked at was multiplication. So for example, if you had 2 cubed times 2 to the 4, you would have 2 times 2 times 2 times 2 times 2 times 2 times 2. You would have 2 to the 7. Algebraically, if you have the same base and you are multiplying, our rule is keep the base and add the exponents. M plus N. Quotient rule. If you had something like we just did on the previous page, where you have 3 to the 7 divided by 3 to the 4, and you wrote it all out, 4 of those 3's would divide out. You would end up with 3 to the 3. To write it algebraically, we would have same bases. If you're doing division, we keep the base, subtract the exponents. Power of a power. We did one of these as well. If you have something raised to a power, that would be the same as 4 squared times 4 squared times 4 squared 3 times. You would end up with 4 to the 6. If we have power of a power, sorry, I don't know why that title wasn't there, we would multiply exponents. So we keep that base and multiply the exponents. Right, having a little time with the smartboard tonight. Power of a product is when we are multiplying things like 3x and we raise it to a power like 4. We mean we have 3x times 3x times 3x times another 3x. So both the 3 and the x would be affected by that 4. It would be 3 to the 4, which would be 81, x to the 4. So if we have a power of a product, which is multiplication, that power, that exponent would affect everything in the product. So it makes more sense, I think, when we put it in brackets. So if you have a b, for instance, to the m, that means both the a and the b would get multiplied by the m. Can we put one that's just a little bit more complicated? If you have a squared b to the 4 to the power of m, you would have power of a product and power of a power both together. So you have a to the 2m, b to the 4m. Power of a quotient is kind of the same idea. If I had 3/4 to the power of 3, similar to the one we did before, it would be 3/4 times 3/4 times 3/4 3 times, which would be 3 to the power of 3 over 4 to the power of 3. So both the numerator and the denominator are affected by that exponent. If you had a over b to the m, it would be a to the m over b to the m. Both pieces are affected. The zero exponent. The easiest way to show you this is to just look at a pattern. If I have 2 squared, which means 2 times 2, it would be 4. If I had 2 to the 1, it just means a single 2. You can see that as I go down the table, I'm dividing by 2, dividing by 2. So it would make sense following that pattern that 2 to the 0 is 1, and it is. Anything you raise to the power of 0 is 1. This is the easiest one. We love it. Okay, a negative exponent. In the same way, if we were to look at, well, never mind, I was going to give away tomorrow's lesson. Leave the last 2 blank and we'll do that tomorrow. Let's do a few examples. I would really love for you to write these down. It's good practice. Okay, first one, m to the 7 times m to the 15, all divided by m to the 20. The first thing I need to check is that all the bases are the same, and all of these have the base of m. So I can use all my rules of exponents. First thing I see is that the numerator has a product multiplication. So my rule for a product would be to add the exponents. So m to the 22 divided by m to the 20. I see that I have division now. My rule for division is to keep that base, subtract the exponents, m squared. The second one, 25k to the power of 15 divided by 5k to the 7. Some of us like to write it out so we can see it, top, numerator and denominator, but you don't have to do that. So I have numbers and I have k's. The numbers don't have the same base, but we can do regular old average division. 25 divided by 5 is 5. Then I have my rule for powers, k to the 15 divided by k to the 7. Keep the base, subtract the exponents, and we're done. Third one, I see power of a product. Things are being multiplied. So I would deal with the 2 first and then the x second. That 3 affects both of those pieces. So I have 2 to the power of 3 and I have x to the 7 to the power of 3. If I have power of a power, I multiply my exponents. I suppose you could tidy that a little. 8x to the power of 21. The next one, the numerator has power of a product and the denominator has power of a product. So I'm going to do the numerator and denominator first, and then I'll worry about division. On the top, I have 5m cubed to the power of 4, and that exponent will affect both the 5 and the m cubed. 5 to the 4. M cubed to the power of 4, I multiply exponents because it's power of a power. My denominator. That square affects both the 5 and the m to the power of 4. So it's going to be 5 squared. And then my m's are power of a power. It would be m to the 8. Now I have division. And I have 2 separate things that have same base, the 5's, and I have the m's. So my rule for division for the 5's would be keep the base, subtract the exponents. For the m's likewise, I would keep the base, subtract the exponents. I suppose you could write that as 25m to the power of 4. And 3 last examples. 27 squared divided by 3 cubed. We could use a calculator and evaluate that, but I can't use rules of powers to simplify. I have to have the same base. I happen to know that 27 is the same as 3 cubed. So I'm going to replace the 27 with 3 cubed. My bottom was 3 cubed already. I'm looking for the same base. And I look at the larger number and see if I can write it with the same base as the smaller, and I can. So my rule of power of a power on the top would be 3 to the power of 6. Divide by 3 cubed. My rule for division is keep the base, subtract the exponents. 3 cubed happens to be 27. The next one has multiplication and division, and my order of operations would say I worked left to right with multiplication and division in the order that they appear. However, I can't use any rules of powers because none of them have same base. So just making a point here, can't use my rules of powers. I can only evaluate. So I've got 16 times 27 divided by 36. I have 432 divided by 36. And final answer would be 12. Just to make a point, we cannot use the rules of powers if we don't have same base. For the last one, I have the same base, 2 to the power of 5 plus 2 to the power of 3. However, I don't have any rules for addition and subtraction. Since powers are multiplication over and over again, it wouldn't make sense to use simplification with addition and subtraction, only multiplication and division. So just to make a point again, we don't have any rules. If we're adding or subtracting, we can only evaluate. 2 to the power of 5 is 32, and 2 to the power of 3 is 8. My final answer would be 40.